Today we're going to start talking about energy transformations. The essential question for this unit is, how can you demonstrate energy transformations? An example of an energy transformation would be a flashlight battery changing chemical energy to electrical energy to light energy. Let's take a look. Energy transformations are also called energy conversions, which is the process of changing energy from one form to another. And then it flows from one type of energy to another type of energy. If you look at our picture, here we see the sun converting energy in solar panels into electricity and into light. When we have an energy transformation, the energy in should equal the energy out. This is called conservation of energy, which means that energy can neither be destroyed nor created. The total energy of the universe is exactly the same as when the universe began. So energy doesn't disappear. It just transforms from one form into another. So for example, electric energy converts to heat energy on a stove. So what are our different types of energy? Well, we have some categories that we can put them in. One category is called potential energy. This is energy that is being stored. It has the potential to do something. So some forms of potential energy include mechanical, chemical, nuclear, and electrical. Another category we have is kinetic energy. This is energy of things that are in motion, things that are moving. So some forms of kinetic energy would be also mechanical, radiant or light, electrical, thermal, and sound. So as we're looking at all of these different types of energy, you can see that some forms of energy fall under both potential and kinetic, and some fall under just one of these. Let's begin with mechanical energy, or kinetic energy. This is the energy a body possesses because of its motion caused by gravity or elasticity. So for example, when water flows, when the wind blows, an arrow shot from a bow, or bouncing on a trampoline. But sometimes mechanical energy can be potential energy. And this is the energy a body possesses because of its position. And it's being stored by gravity or elastic potential. These would be things like the book on a table. It has potential to fall and be in motion. A compressed spring, which has potential to release, or a rubber band pulled back, like in this picture. Can you follow the energy flow? Here we see mechanical energy of the wind blowing the blades and turning them, which is also mechanical energy, causing the turbine to pump. Let's take a look at thermal energy, which is also kinetic energy. This is heat energy, the total energy of atoms and molecules that are constantly in motion. So for example, the burner of a stovetop when it's turned on, or a hot cup of cocoa, or even a fire. Can you follow the energy flow here? So we saw the wax being used as a fuel, and that's a form of chemical energy. It's being converted into thermal energy with the heat of the burning wick, and finally into radiant energy, which is what we use the candle for light. So radiant energy is exactly that. It's referred to as solar or light energy. This energy is caused by the movement of what we call electromagnetic waves. So for example, the light emitted by light bulbs, the sun, or even the waves from a microwave. Can you follow the energy flow? Here we see radiant energy from the sun being converted into chemical energy through the process of photosynthesis in plants. And then the plants convert it to a different kind of chemical energy, which the deer eats as food. Sound energy is considered kinetic energy. It's the energy in the form of wave motion. And this is that vibrations spread in all directions as one vibrating object touches another, causing it to vibrate. So for example, hitting a drum, a tuning fork, or even talking. Can you follow the energy flow? Here we see solar energy, the potential solar energy in the sun, being harvested by electrical energy in the solar panels on the house. This is being converted into electrical energy, which is the electrons flowing through the wires in the house, over to the radio, which is sound energy or motion of waves coming from the music. Electrical energy is kinetic energy because electrons are moving from one point to another point inside what we call a conductor. So for example, the electric current in wires, lightning, and electrical energy also has potential energy, which is stored electrons that are not yet moving. So let's say that light bulb is turned off, or the stove is turned off, or when we have something like a power outage. The electrons in clouds. Can you follow the energy flow? Here we see the electrical energy of lightning converted into thermal energy of fire. Chemical energy has potential energy. The energy is stored in chemical substances, like for example, fuel, explosives, the food you eat, batteries, or even wood, which will burn in your campfire. Can you follow the energy flow? Here we see the chemical energy in a battery converting to electrical energy as those electrons flow through the wire and into the light bulb, which eventually converts into radiant energy or light. What about nuclear energy? Nuclear energy is potential energy or atomic energy. The energy is stored in the nucleus of an atom. This energy can be released by fusion, which is when we take two nuclei of an atom and combine them, or fission, which is when we split up those nuclei. So for example, nuclear power plants use fission, or splitting of an atom's nucleus, to produce power. And the sun is actually fueled by fusion, or the combining of a bunch of atoms' nuclei. Can you follow the energy flow? Here we see nuclear energy from fusion being converted into mechanical energy when a turbine turns. This is then converted through a generator into electrical energy into wires, which is sent to something like a city. So, from this, can you demonstrate energy transformations?